For our example number 4, what if we have our y is equals to arctangent of a plus x over 1 minus ax. Okay, so let's try this one. So at this point, we could be able to use let v. Let's try m. Let m is equals to a plus x over 1 minus ax, and then we could be able to rewrite this one. We could say that our y is equals to tangent or arctangent of m, and then we could say that we could use the equation number 3, and then our dy dx is equals to the dm dx over 1 plus u squared. Oh no, sorry, m squared. Okay, so they are just the same. So we derive so we are involving u here. So du dx over 1 plus u squared. So in here, we use m. So our angle is m. So dm over dx over 1 plus m squared. So at this point, so our m is already given. So next step is, how are we going to, we must think find what could be the possible formula or technique that need in order for us to solve the dm over dx. So let's use we have our m here, so huwag niyong pabayaan yung m, at saka we're going to solve for the dm over dx. So at this point, we could be able to let's say our m is equals to u over v. Okay, so our u is equals to a plus x, and then our v is equals to 1 minus x. Okay, so we let u is equals to a plus x, and then v is equals to 1 minus ax, and then we could be able to derive it directly. Du dx is equals to a, no, this is 1, this is 1, and then our dv dx, this is automatic equals to negative a. So if we are going to rewrite our equation, our m is, so this equation, we could be able to write this as m is equals to u over v, and if we're going to derive the dm with respect to dx, which is, this is already what we are looking for. This is our answer, or dm dx is equals to v, the derivative of u with respect to x, minus u, the derivative of v with respect to x, over the square of v. So let's substitute. Dm with respect to dx is equals to v is 1 minus ax, du dx is 1 times 1, so u is a plus x, then our dv dx is equal to negative a over the square of v squared, which is 1 minus ax squared. So at this point, we could be able to solve for the dy dx, which is our dy dx now in here. Dy dx is equals to dm dx is, okay, so let's try to simplify this one first. So our dm over dx, this is equal to 1 1, our numerator first, 1 minus ax minus, since this is a times, you can see, this is a squared plus a squared negative, so automatic a squared plus this is uh, so this is negative times negative is positive, a squared tapos negative plus ax. Okay, so over 1 minus ax squared. So we could cancel out the ax. Negative ax plus ax is equals to 0. So therefore our dm, the simplest form for our dm with respect to x, or the derivative of m with respect to x, is equals to 1 plus a squared over 1 minus ax squared. So again, we need patience. So let's now try to substitute this one in here. So let's try to solve in our general formula, which is dy dx equals to dm with respect to x divided by 1 plus m squared, which is based on our in this theorem, in the third formula that we had. So dm dx is equals to 1 plus a squared over 1 minus ax squared divided by 1 plus m natin is equals to, so let's check kanina, our m is equals to a plus x divided by 1 minus ax. Okay, so our m is equals to a plus x divided by 1 minus ax squared. Okay, so in here, so at this point, so let's try to simplify this one. So mahaba pang usapan to. Let's try to simplify. Okay, so let's go there. So dy dx is equals to let's try to use or find the LCD in the denominator. So 1 plus a squared over 1 minus ax squared over 1, if our LCD is, okay, so let's try muna ito. So 1 plus, this also equals to 1 plus ax squared over 1 minus ax squared. So let's try to, so our answer would be 1, let's copy the numerator, 1 minus ax squared over, so let's find the LCD in the denominator. This is 1 minus ax squared, so multiply in the 1, so we have here 1 minus ax squared plus a plus x squared. So at this point, we could say that so we could cancel out this one, and the remaining is 1 plus a squared over 1 minus ax squared plus a plus x squared. Okay, so let's try, so let's solve this one. Okay, so next step is we need to solve for, let's simplify. So let's simplify the denominator. 1 plus a squared over, so this is equals to 1 minus, so the square of 1 minus ax is equals to 2ax plus a squared x squared plus this equals to a squared plus 2ax. So the square of a plus x is equals to a squared plus 2ax plus x squared. Then we use, so let's copy the numerator. So we could cancel out the 2ax. Then we have the remaining 1 plus a squared plus a squared x squared plus a squared plus x squared. So at this point we could be able to segregate so x squared. So let's try 2x squared a squared plus 2x plus x squared. So we have, so okay, so overall this is equal to 1 plus a squared over, so if we group them, let's group 1 plus a squared plus a squared x squared plus x squared. So if we're going to group them into like this, so I think we could be able to try to cancel groupings. So 1 plus a squared plus is equals to 1 plus x squared. Okay, so in here we group so this is equals to x squared. So in here we try to factor out the x squared in here, and then the remaining would be a squared plus 1, and then also, so based on this equation, so we could be able to factor out, we could say that this is equals to 1 plus a squared over 1 1 plus a squared times 1 plus x squared. So therefore we could cancel the 1 plus a squared. This equals to 1 over 1 plus x squared. So this is our dy dx. This is our answer. Our last example is we have our y is equals to x times the arc cosine of x when our x is equals to negative 1/2. So at this point, we could, based by inspection, we could say that we are going to apply the product rule. So we let u is equals to x, and then v is equals to the arc cosine of x. So at this point, let's solve for du dx. This is equals to 1, and then our dv dx, this is equal to, we could be able to use the second equation, and then this is equals to negative negative du dx, wherein our u, or this is x already, is equal to the negative dx over dx over the square root of 1 minus x squared, Okay, so this is our kumbaga pinaka-yun niya. So, okay, so overall, if our dv with respect to x, this equals to negative 1 over the square root of 1 minus x squared. So, at this point, based on our given, since we let u is equals to x and v is equals to r cosine of x, so we could write our given equation into u times v, and then its derivative with respect to x is equals to u dv dx plus v du dx. So at this point, dy dx is equals to, so we could try now to substitute. U is equals to x, dv dx is equals to negative 1 over the square root of 1 minus x squared, plus v is equals to cosine r cosine x times 1. So this is already, so now we could be able to use the, let's try to to comply the requirement that when x thou is equals to negative 1/2, what would be the value of dy dx. So using this one, so we just need to solve. So to solve for the, so we are going to find for the dy dx when our x is equals to negative 1/2. So to solve for, so what we need to do is just substitute this one in here. So again, to solve for the value of the algebraic function, you should set your setting in the calculator into degree mode. Okay, if it's under the algebraic function. If you are involving with the cosine or trigonometric function, you are going to set your calculator in a radian mode. Okay, so if you, so this is if we are in trigonometric function. Okay, so again, since we in our first term, since we are involving in under the algebraic function, you must set your um calculator in degree mode. And then if we, in our second term, we are involving with trigonometric function, we need to, or you need to set your calculator into radian mode. So our dy dx, so if we are going to substitute the x is equal to negative 1 in our first term, wherein our your setting is under degree mode, this is equals to 0.57735 plus, then in here the value of r cosine of x, wherein we are in the setting of radian mode, our x is equals to negative 1/2, our answer is equals to 2.0944. So overall, our dy dx is equals to 2.672. So this is already our final answer.